Plotting polar graphs. Here's what you need to do. Yes, you know, no back up. Okay, so when you're plotting polar coordinates, polar graphs, you need to plug in key angles for theta into the equations. You need to plug in 0, pi over 2, pi, and 3 pi over 2. You do not need to do more than that because, remember, these are sine and cosine, and what happens if you plug in 2 pi, which would be the next one that's the same as 0. So it kind of loops around. These are the only points you need to plug in, and then you need to connect the dots. Okay? Now, there are essentially 3 types of graphs we're going to cover in here. Or actually 4, because we're going to get to the next ones. The Archimedean spiral, which is very similar to the circle. Remember, the circle was r equals theta. That was the circle. Okay. This one, r equals some constant times theta. If a is larger than 0, i.e. positive, it spirals out from the center in a anti-clockwise, talking British, fashion. If a is smaller than 0, it goes the other way. So if you have a negative theta, that's what they look like. And there's a sample equation. And they will actually, like I said, they'll be easy to graph. You make a table of values for 0, pi over 2, pi, 3 pi over 2. Plot those points. If it's a spiral, it spirals out following those coordinates. Either direction, negative or positive, you do graph and plot the points. And remember, these are polar coordinates that we're plotting, so you're using polar graphs. On your notes, you have polar graphs. On the worksheet, you have polar graphs. But I do have a great big giant stack of graph paper that has polar graphs on it if you want to use it. Because Cartesian doesn't make sense. Okay. Next one is a little more complicated. Cardioid. R equals A plus or minus A sine theta. They have vertical symmetry, which means if you fold it on essentially the y-axis, it will line up on both sides. If you have A plus or minus A cosine theta, you will have horizontal symmetry when you do that. In other words, it will fold on the x-axis. Notice, and this is extremely important, notice the constant in front and the coefficient of your trig function are the same number, plus and or minus. That is important. That's what makes it a cardioid. And an example of what one of those looks like. These are going to be gnarly looking graphs. These are pretty special graphs. Okay, and then the next one, Limason or something like that. I can never pronounce it correctly. I really don't care. A plus or minus B sine theta. Gives you, once again, vertical symmetry, but sine, it has vertical symmetry. R equals A plus or minus B cosine theta gives you horizontal symmetry. Notice the A, the number out front, the constant in front, and the coefficient are not the same number. Difference between a cardioid and a limicon is two numbers are the same, plus or minus, or they're not the same, plus or minus. And then the graph for these are quite different indeed. They have a loop in them. They actually loop around inside themselves. This is the difference between them. And you'll see them a little bit better when we graph them by hand. It's hard, I know it's hard to see here. Let's do this for a minute. Notice the cardioid, it has a little hump in the middle. The limicon's got a loop in the middle. Okay, and you'll see that more, and it'll become more prevalent when we graph them. And for all of these, it's make a table of values, plot the points. Okay, ready for the next page? So let's do some graphing. So when you're doing these, make a table of values and graph. Theta is your x value, r is your y value for your table, 0, pi over 2, pi, 3 pi over 2. And remember, you're plugging those values in for sine and cosine. They're going to be relatively simple values to figure out. They're all going to be 0, 1, or -1. For every single one of these for sine and cosine, for those values, you're either going to get 0, 1, or -1. So it's not that big a deal. So this one's going to be, I have these two numbers here the same, although it's plus and minus, it's still the same. Yeah, I can never spell it right either, and I don't really care. It's not like that. But here's what I think part of the reason you want to recognize it is, does it have a loop in it or not? The cardioids do not have a loop in it. This is cosine, this is going to have a horizontal symmetry. Plug in the points one at a time. Cosine of 0 is 1, right? Yeah. So 1, so 2 minus 2, so I get 0 for r. Plug in pi over 2. Cosine of pi over 2 is 0, so I get 2 for r. Pi, I get -1 for pi, for cosine, so I get 2 plus 2, so I get 4. 3 pi over 2 is, once again, 0 for the cosine, so I get back to 2 again. And I plot these points according to, remember, their polar coordinates. Find the angle, do it. So the point 0, 0 is still the point 0, 0.
Yeah.
Right? The origin is the origin is the origin. And then I have the point pi over 2, 2. So this is, remember, pi over 2 is straight up. So I go to here. I go to pi 4, 1, 2, 3, 4. This is the point pi 4. 3 pi over 2, 2. 3 pi over 2 is down, 1, 2 out. Those are my 4 points. And it starts here, loops out and through, and then around, and then back, something like that. That's it. Okay? This one is a Limousin. How do I know? Because the numbers in front are not the same. I've got 1 and 3. They're not the same. These two numbers are not the same. I'm going to have a loop in it rather than just a hump. Song. French song. I don't remember much of my high school French, but I remember a little bit. Okay, set up a table of values. Okay. Plug in the values. Sine of 0 is 0, so I get 1. Sine of pi over 2 is 1, so this gives me 4 for this. Sine of pi is 0, so I get 1 again. Sine of 3 pi over 2 is negative 1, so this gives me negative 2 for my value. Plot the points. 0, 1. Pi over 2, 4. Pi is 1. And then 3 pi over 2, negative 2 is up here. Remember, 3 pi over 2 is the angle down, but what direction we're going? We're going in the negative direction, so it's going to go up instead of down. And then I start here. I go up through there, down through here, loop through that one, and come back down. Yes?
Are we going to have to memorize what type of like circle it is, like cardio in the soul?
The only reason to really do that is to make it, remember how the graph is going to look. You are not going to have your graphing calculators for the test. You will not be able to graph them and then plot them from your graphing calculator. You're going to have to know how to do it by hand. And it's nice to know which one's which in order to know what the graph is going to look like. That's really the only reason why you know the two of them. Does one have a loop in it or does it not have a loop in it?
You don't have to know the names.
What?
You don't have to know the names.
No, you don't have to know the names. It helps to be able to recognize and know the difference of them in order to make it easier. Okay. Okay. Ooh, what's the next one going to be?
The first one.
The spiral. What's my A on this one? Negative 1.
What?
If it's 1, you have a circle. Or actually, no. If it's constant, if it's R equals some constant, you have a circle. You have theta in there, you've got a spiral. Now this one's negative 1. Still makes it easy. Set up the thing, same thing. So 0, pi over 2, pi, 3 pi over 2. This would be 0, negative pi over 2, negative pi, negative 3 pi over 2. Ooh, that's so hard. Except, here's the thing. When you're plotting out the graphs, you have to understand the values of pi and pi over 2 and the stuff in order to be able to plot the points approximately. So I still start at 0, 0.
It's just making them all negative.
Because it's negative in front of it, right? Negative theta, right?
Okay.
Okay, now, so pi over 2 is straight up as the angle, right? The units that I'm traveling on that are also pi over 2 units. Pi is approximately what? 3.14. So half of that is approximately a little bit more than 1.5. So although pi over 2, the angle goes up, we have a negative, so we're going to go down about 1.5. Because pi over 2 is about 1.5. Because pi is a little more than 3, half of that's a little bit more than 1.5. Okay. Next one, pi, the angle goes out this way. But I'm going to go negative pi, which means that I'm going to go -3, a little bit more, out to here.
Wait, are you on the line or are you?
I'm on the line. I'm a little bit past 3, past the circle, but I'm on the line.
No, wait, are you on the circle line or? Are you...
I'm just a little past, because what's 3? What is pi? 3.1, not 3. Right? It is not exactly 3. No matter what Professor Fink says. And then 3 pi over 2 is -3 pi over 2. So 3 plus 1.5 is 4.5. So it's a little bit more than 4.5. 1, 2, 3, 4.5. And it's going to go like that. Okay, give that next one a try. Make a table of values, plot it out, see what you come up with. Okay. So I end up, cosine of 0 is 1, so I get 5. And pi over 2, it's 0, so I get 3. At pi, it's -1, so I get 1. At 3 pi over 2, I get 3 again. So you plot out your points. 0, 5. And then pi over 2, 3, 1, 2, 3. And then 1 for pi. And then 3 again for that. And you start here and you go. It doesn't always have a circle. That was my mistake. I'd forgotten. A cardioid tends to be a little bit more symmetric and a little bit more rounded than this one does. Plot the points and go through it. Some of them have a circle. Depends upon where the point is, comparatively speaking. Any questions on these? Make a table of values, plot the points, start at the first one and go through them in order you have. Yes?
I thought it wouldn't be a cardioid because
it's still a lemmason because it has the two numbers that are different, but they will often look almost identical. Really what's happening here more than anything else is the elongation going out. Tends to be a little bit more. Sometimes they have loops, sometimes they don't. Just plot the points and loop it out. That's the best thing you can do. Okay. Now we get to the fun ones. Yes. Roses. Apropos, it's Valentine's Day just around the corner. We're going to be doing roses. Hey. The basic equation for a rose. R equals A sine n theta, or R equals A cosine n times theta. So you have a coefficient in front of your sine or cosine, and then it's not just theta, it's some number times theta, like 2 theta or 3 theta or something. If n is odd, there are n petals. So if I have the cosine of 3 theta, I have 3 petals. If I have the sine of 5 theta, I have 5 petals on my rose. If I have the sine of 21 theta, I have 21 petals on my rose. No, I would never do that to you. If the number in front of theta is even, there are 2 times that many. So if I have 2 theta, that means I have 4 petals. If I have 6 theta, that means I have 12 petals. If I have 4 theta, I have 8 petals. Now, for a cosine rose, The first petal is split by the positive x-axis. So it's always split by the positive x-axis for a cosine. Divide 2 pi by the number of petals to find each increment. In other words, how many times am I going to go around for the number of petals and how far apart the tips of the petals are? What the angle is that I go out for the tips of the petals. So it's 2 pi either divided by n or 2n, depending upon whether n is odd or even. So you got to know the difference between odd or even. You'd be surprised. Okay. For a sine, set n theta equal to pi over 2 and solve for theta. This tells you the tip of the first petal. On the cosine, the tip of the first petal is always on the x-axis straight out from 0. For the sine, it varies depending upon how many petals you have. That will tell you your first angle, and the first one is the hardest one to find. Once you find that first one, the other ones tend to fall into place. And then the same rule for the increments, divide 2 pi by the number of petals to find each increment. In other words, how far apart angle-wise the petals are spread out. And I think you already have some of that cleaned up on yours, if not all of it, right? Okay. Let's do a couple of these. So the first number out in front, A, is how far out we are going. This is our distance out. All our points, all the tips of all of our petals will be 4 units out. I have a cosine. I know where my first tip of my petal is going to be. It's going to be here because I have a cosine. The cosines are always on the x-axis. That's where the tip of my first petal is going to be. 4 circle out on the x-axis. Cosine, 4 in front, that's where it's going to be. Now, how many petals do I have? I have 5 petals. If it's odd, it's the number in front of the theta. That's how many petals I have. I have 5 petals. To find my spacing, what do? Look at your notes. Ooh, 2 pi divided by the number of petals. 2 pi over 5. That's the spacing between each petal. Boy, that sucks, doesn't it? That really sucks. 2 pi over 5. Where is 2 pi over 5? Well, no, you're not going to get it exactly, but you can get pretty close, right? So 2/5 of the way around, halfway around the circle. Halfway around the circle. So remember, 1 pi is all the way across. So I start here, this is 0. I go 2/5 of the way up, it's going to be about here. Okay, because 2/5 is between 1/3 and 1/2. Because I know my fractions. 2/5 is less than 1/2, right?
I know.
And it's more than 1/3. It's a little bit less than 2/2. Because 2.5 divided by 5 would be exactly 1/2. It's a little bit less than that. Okay. And by the same token, this would be about where 4/5 is. And I add another 2/5. And remember, if it's cosine, it's symmetrical around the x-axis. So every one I have above, I have a matching one down below. So I have one here, and I have one here. Those are the tips of my petals. So once you get the tips, drawing with those is actually very easy. Ready?
Pull.
Now. Really, that's it. Now, if you graph a rows on your calculator, it will not plot the points, it will not draw the line in the same way I did. It actually will loop around, and you can kind of see how the loops go. They kind of go like this. That's how the loops go, is they kind of go through like that, and that's how it will draw it on your calculator. It's really actually kind of cool to watch. Okay. Okay. Yeah, but you have to do it by hand, so that way you can do it on the test. Okay. So, same thing. I have rows. First of all, how far out am I going to go? 5. So these are going to be on the outer circle. All the points are going to be on the outer circle. How many petals do I have? I have 3 petals. Oh, this makes it nice. So my increment is, or actually I need to find the first one first. I need to find the first petal first. Because sine is different. Sine is not on the y-axis, the x-axis. The sine, in order to find the first petal, you take the first tip, you take the number of petals, 3, or actually 3 theta, set it equal to pi over 2. You set what you have, what you're taking the sine of, equal to pi over 2. That tells you where the first petal is. Solve for theta, multiply both sides by 3, or divide both sides by 3, sorry. Theta equals pi over 6. Oh, good. That's an easy one. Pi over 6 is that first line coming out. There's the tip of my first petal. Now, to find the distances, I take 2 pi divided by the number of petals. That's the distance between each petal. 2 pi over 3. So my first petal is at pi over 6. My next petal is at pi over 6 plus 2 pi over 3. And these I can add together, get a common denominator. 4 pi over 6, 4 plus 5, ooh, at 5 pi over 6, which would be here. Yes? Yes. Divided by the number of petals. Because we're odd so far, it is the number in front of theta. Then if I want to find the next one, I take where I was, 5 pi over 6, and add 2 pi over 3 to that, which gives me 9 pi over 6, which reduces to 3 pi over 2, which is straight down. And that makes sense. If I've got 3 petals, it should be symmetrically broken up into even thirds. And then you draw your rows. Questions? Okay. So how far, what ring are we on? 3. So this is our distance out is 3. So everything's on the 3. How many petals do we have?
Wow.
We have 12 petals because this is even. We have 2 times 6, which is 12 petals. Okay. To find where the first petal is, I take 6 theta, set it equal to pi over 2. My first petal appears on pi over 12. Well,
Right here. Right here.
that's halfway between 0 and pi over 6, right? Okay, now we get to have some fun. How far apart are all the petals? Yeah, they're all 2 pi divided by 12, so that means they are pi over 6 apart. So if I take pi over 12 and add pi over 6 to that, that gives me 3 pi over 12, which is pi over 4. So my next one over is a pi over 4. And then I add 1/6 to that. That puts me here. And then the next one puts me here, and then 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 here. Yes, ma'am.
Why are you adding by 3 pi?
Because what do? You take 2 pi. I'm starting at pi over 12 because to find the first one, you take that, set it equal to pi over 2. So pi over 12 is my first one. How far apart are they? I take 2 pi divided by the number of petals. They are pi over 6 apart. So every pi over 6, I have a new one. Once you find the 12 dots going around, that one actually looks more like a rose than a rose. Yeah, actually, I think it does look like a daisy. I like daisies.
Wait, not all.
Yes.
Can I run into the room? I forgot my math.
Okay.
Oh, right.